All right, good evening. Does this work? It does? Okay. So, a reminder, you should have accepted the invitation to join ED. About 60 still haven't. That's an issue, of course. I have updated the course outline because we now have more consultation. So Matthew posted a message about online consultation, but actually at the same time, we have the beginning of a face-to-face lecture. So make sure you know the days and times of consultation. So what is outlined there? All right, so Tuesday, now we have a second consultation from 6 to, that's wrong. We had 4 to 6, right? And now we also have 6 to 8. So I have to fix this, good that I have a look. Then one more consultation on Thursday, and still the consultation on Friday, all right? So Tuesday, 4 to 6, and 6 to 8, Thursday and Friday. So make sure you go to consultation whenever you need help, not only because you are stuck on a quiz, on assignment, but to get feedback, right? Make sure you don't bother with just what is assessed, not just quizzes and assignments, then spend time beforehand to read the notes, to work on the practice exercises, right? You will first, of course, gain much better skills. And second, you are going to save time, not waste time. Because if you haven't looked at that before, you won't know where to start, and eventually you spend more time, right? So there's nothing to learn by heart, all right? So as we go through problems, as we see Python syntax and more of that, you don't learn these things by heart, but you find out that with Python you can loop, you can perform tests, you can work with lists, and so on, right? And as you think on a quiz, first how to solve it at a high level, and then, okay, let's try to refine this high-level solution into something I can eventually convert into Python code. You will know that, okay, for this I need a list and I need to perform this operation on a list. What exactly, I don't remember, but I know I've seen that in these notes or in this exercise, and then you refer to that, right? So you're going to refer to the notes, to the sample programs at the beginning, and then less and less so as you eventually use this syntax more and more, and eventually it becomes natural, right? But there's nothing to learn by heart, it's just things to understand, and then be able to refer to what you have seen at some point, which you know is more or less what you need. All right? And also remember that the task is not to convert whatever instructions into Python code, but it's really going from a particular problem to Python code and test it. And the first stage is, of course, to first understand the problem, then come up with the right idea, make this idea more and more precise, and only then start writing the code, right? So don't think I have a quiz to do, so I have essentially to submit a piece of code. So let's start typing, okay? It doesn't work this way. So if you think about it early enough, then you can go to the Thursday, Friday consultation to get support. So don't go to consultation saying, you know, can you help me? But of course, make some progress, know what causes problem, and go there to have this problem resolved, right? So ask precise questions. Then you have the whole weekend and Monday to make further progress, and if you are still stuck, then you have Tuesday consultation, afternoon and evening for that. So you have plenty of support, right? Monday, Wednesday lectures, Tuesday, Thursday, Friday consultations, so we can't do more, so take advantage of that, right? When you post questions on the message board, make sure you first check whether the question hasn't been asked and answered already. Right? So take a few seconds to have a look at what has been posted already. And that's pretty much everything I wanted to say before I start. Do you have any question in general on? No question, everything is clear? Sure. All right, so we start looking at the second set of notes. So in these notes, we'll learn about more about lists. We'll learn about exceptions. We'll learn about sets. We'll learn about default arguments to functions. So again, all kinds of things. So we enforce what we have seen already, and we learn much more stuff. So, problem. So that's the Monty Hall game that I guess many of you know already, right? So it's a kind of TV show where you have a host and a contestant, and on stage you have 3 doors. Let's label them A, B, and C. Behind one door, there will be nothing. Behind the second door, there will be a goat. And behind the third door, there will be a sports car. And of course, the contestant doesn't know what is behind which door, right? And the contestant, of course, wants to win the goat, right? No, the sports car, of course. So the host will ask, what door do you want me to open for you? Where do you think is the car? What door do you think is the door behind which the car is hidden? So the contestant will choose one of A, B, or C. And then the host will open another door. But of course, not the door behind which you have the car. All right? So either the door behind which there is nothing, or the door behind which there is the goat. And then he will ask the contestant, now do you want to stick to your choice, or do you want to switch? So do you want me to eventually open neither the door you have chosen in the first place, nor the door I have opened? And the contestants can opt for either strategy. So what is the best strategy? So in other words, if you had to play this game many times, what would be your expectation of winning in the long run? So would you switch or not switch as a strategy? Switch, you all know, okay, so why? Because if you don't switch, what are your chances of winning? Clearly 1 out of 3, right? We have an equal chance to have the car behind A, B, or C. You choose one door, that's the door that will eventually be opened, so 1 chance out of 3. On the other hand, if you decide to switch, either you choose the right door in the first place, in which case, of course, switching makes you lose, or you choose one of the wrong doors. So either you choose the door behind which there is a goat, of course you don't know it, then the host opens the door behind which there is nothing, and by switching, you win the car, right? And the other way around, if you choose the other door. So by switching, you win 2/3 of the time in the long run, right? So essentially, we want to simulate this game. So play this game a number of times. So we let the user decide how many times we want to play this game. And we want to randomly put the goat and the car behind doors, randomly let the contestant choose one of the 3 doors, and randomly let the host open a door in case he has the choice, right? In case the contestant chooses the door with the goat or nothing, then the host has no choice but to open the other bad door, right? In case the contestant chooses the door with the car, then he has 2 choices, okay? So again, he could choose randomly. All right, so that's what we want to do. So we're not going to let the contestant randomly choose whether to switch or not switch. but systematically always switch or systematically always not switch, so that we can eventually get statistics and check that our understanding is correct. So we need first to prompt the user to ask what he wants, and then we need to run the simulation. Yeah, if anything is not good, not big, let me know, because I won't see that, and I need your feedback. So let's again use Jupyter for this to run and write and execute code incrementally. So we want to prompt the user, right, for input, and the Python input function lets us output a prompt. So provide a string as an argument, which will be the prompt, what will be displayed. How many times would you like to play? And the input function prompt the user. So you see it's probably nicer to put a space. Oh, it was waiting for me to provide input, which I didn't do. So let's stop the kernel, start again. Now we have a nice space after the prompt. So let's say 10 times. And what does input return? Not the number 10, but the string 10, right? So of course we could number of times to play is what's written by input, and we could then apply, in order to convert this string into an integer, we could then apply int, right? We have seen that last week. And that works, but we can directly, right, pipe the output of the input function to int, right? So make the output of input the input of int, in which case number of times to play is what we want, unless, of course, I don't provide valid input, right, which happens a few times. And we should not assume that the user always provides valid input. So you see what happens in case my input is not valid. What do we get? We get a value error exception raised by who's responsible for outputting value error? It is int, right? Input can't fail. It's very hard to make input fail. So what we do, we try to do this. Right? We try this to work. And in case to work, it works all good. Otherwise, in case something goes wrong, then the code will jump into the except clause associated with try and see if the error which has been triggered in some way is one of those we are keen to handle. So here we're keen to handle a value error. So we say in case the code doesn't work and a value error is generated, then this is what we want to do. So what do we want to do? We want to say to the user that the input is incorrect. Try again. Is that going to help? Yes, if this is followed by prompting the user again, right? Because now, if I type 10, I get this, all good. So to try again, of course, the user has to be prompted again, right? In other words, this code should be part of a loop, right? Either for loop or while loop. So if we know how many times we want to loop, usually we use for. If we don't know, we use while. So for as long as some condition is true, so for as long as we don't have valid input. Okay, so we have a number of ways to do that. We could, for instance, say valid input. That's a flag that we set to, when we start, do we have valid input? When we start? No, right? So we set it to false. And we say that for as long as valid input is false, if you like, or for as long as you don't have valid input, for while not valid input, then we loop, right? Make sense? So 10, not good. 10, not good either. 10, oh, that's good, but still prompted. What is missing? Of course, I have to say that in case the input is valid, and I know that because I don't jump into the except clause, so no exception, no error is triggered by this, right? So if I reach this line, means the previous line executed properly, so I could make valid input. I should set valid input to true, right? Now I've got some valid input. And then when I go back to my loop, not valid input is true, so not valid input will be false. And since the condition of the loop is false, I will exit the loop, right? So if I can get out of the loop, then I should have a number of times to play correctly initialized. So again, so 10 times, exclamation mark, 10 times, all good. Okay, that's one way. Another way is not to use a flag. So have instead an infinite loop. So how do we get an infinite loop? I don't seem to be able to copy and paste. There we go. So if I don't want to have this kind of structure, I can instead have an infinite loop with while. So something that is always true, right? What is always true? Well, true itself. True always equals to true, right? So forever, try to give me some correct input. And in case I reach this line, then I want to say, okay, now I've got what I want. I want to exit my loop, right? I want to break out of the loop. See? So if this raises an exception, you jump there, you go back to the top of the loop, which evaluates to true, whose condition evaluates to true, and you try again to get correct input. And as soon as you get correct input, because int doesn't complain, then this way you get to that line and you break out of the loop. So 10 times, 10 exclamation mark, 10. Still not. Oh yeah, of course. Fine. Now, are you happy with that, or do you think it's still not the most robust piece of code? So are we sure that the user gave us the kind of input we want? well, we have eliminated some invalid input, but maybe not all of it, right? What if the user enters -10? What will happen? Int is happy with -10, right? But probably not something we should accept as valid, right? So we want to play at least once. So what should we do? We should, at this point, instead of breaking out immediately, we should test if this number we've got is strictly positive, right? So in case it is not strictly positive, so less than or equal to 0, what do we want to do? We want to jump into the except clause, right? No difference whether the input is not an int or not a good int. So how can we jump into this clause, the except clause, by raising the kind of exception that int raises itself, right? So in that case, I raise this value error, and the effect of that, of course, is for the except clause to figure out that value error has been generated either by raise or by int, and complain and go back to the top of the loop to prompt the user again, right? So now 10 not good, -10 not good either, 0 not good, but 10 that's right. Okay? Fine? So now we want to prompt the user and ask whether he or she wants to switch or not, right? So I guess same kind of input, same kind of structure, sorry. Okay, so we probably want to prompt the user to find out if we should break. Okay, so if he wants to switch or not, would you like to switch? The answer should be either yes or no, I guess. So in that case, a string is fine, so we don't let int convert the output of input to an int. And I guess eventually, so we want to assign that to a variable which could be called switch, right? What will be the value of switch? What I said, we're happy with yes or no. Is that the case? I guess we want to say true or false, right? So switch should be either true or false. So we have a bit of work to do to convert the input, user's input, into true or false. So we'll be happy if the user says yes, no. So of course we can be more or less stringent on what we accept as a good input. So we could say we accept yes, we accept no, we can accept lowercase, and why not just y, just no, just n, either uppercase or lowercase. Of course, we could accept more, right? We could accept ye, whatever, right? But for the sake of the exercise, we just accept this as very clear, acceptable answers. Right? So of course we could check all of them, right? So what is written by input is a string. Is this string yes, uppercase or lowercase to start with y, uppercase or lowercase? In that case, we set switch to true. Otherwise, we check if the input is one of these four and set switch to false. Not very elegant, right? So what would be nicer is first to normalize all options, right? So what does normalize mean? It means when you have a number of options, you map them all into something which often is one of the options, right? So it could be that you map all these 4 options into this one, which somehow is the standard option, the most natural option, right? And then you're going to check that the result of the normalization is what you want. All right, so here we could, how can we normalize? By mapping everything to lowercase, right? So if we map this and that both to yes, and if we map this and that to no, then we are left with checking whether the input is yes or, and of course do the same thing for y, right? So map this to y, map this and that to lowercase n. So then we are left to checking whether the input is one of yes or y, all lowercase, or one of no or n, all lowercase. So what can we do to normalize? I guess there should be a string function, right, that converts this into that. So which string function? How do we find out what string has to offer? Do you remember? Dir str lists all string methods. What if we want to eliminate what are the special methods and only keep those of interest? What could we do? We have the technique for that, right? We could define a new list. We can define the list of every output, every x in dir of str if, actually we haven't seen that yet, but it's a new form of list comprehension, right? We have seen list comprehension last week. X for x in this, right? In case if x doesn't start with, which we have seen last week, underscore. All right? We look at the list of every x that we find in dir of x under the condition that this x does not start with a hyphen. What's wrong? Starts with. Right, so now we have the list of all good methods. So which one would be good to convert to lowercase? Lowercase, we have a look, L, lower. So I guess lower would be a good candidate. Lower, yes, doesn't work. Lower is a method of the string class, which means if I have a string, I can apply to this string the lower method, right? We'll understand this syntax much better later. For now, we just get the idea that it means apply, dot means apply this particular technique, this particular method, function, to this thing, a string, and the string indeed has as possible methods lower, as we saw before. Right? If we convert yes this way to lower, yes that way, so you see what lower does. It essentially ignores, doesn't change anything which is not an uppercase letter, and all uppercase letters are converted to lowercase. Right, so if we normalize by applying lower, Is that good for what we want to do? Not quite, because we haven't said that this or that are valid input, right? We don't want to accept this. So we want to say we want to normalize only what needs to be normalized, because actually it starts with a capital letter. And if we have a look at the title method, so you see, besides D, you also have the help function that you can apply to either something like str, but then you get a huge output, right? So probably a bit overwhelming. Much more useful is to apply to str.title. So one of the methods of str, and it tells you how this method works, right? So a good way to proceed is to first use dir to get the list of everything this class has to offer. And once you have identified a particular method, then you use the help function to get the details of how this function is supposed to work. All right? Combination of D and help works well. So that's probably what we want. Yes, but it's not what I want. It returns a new string, convert a string to capital letter. All right? So actually, this help function tells me, no, it's not what I want. I don't want to convert the string. I want to find out if my string is title. Does that, okay, we have seen is-space last week, so we have a number of things that start with is. So is title is probably better. Yeah, returns true or false, right? So yes dot is title returns true. No, it doesn't return true. It should be a capitalized work, like this, all right? This is true. This is false. This is false as well. So it looks like it's a good function, even though we don't need so much. Yeah, it's a good function because it checks that only the first letter is capitalized, which is exactly what we need, right? Only the first. So let's get back to this. So we said actually switch will be true or false, but we need to massage the output of input. So I guess it's better to give that another name, like yes or no, and say if yes or no starts with a capital letter, so is title, then we normalize, right, which means we convert it all to lowercase. What we have seen before, lowercase, that's the job of converting a string into all lowercase. Okay? So it's a capitalized word. Let's normalize it. And now at this point, we can check if yes or no is one of yes or y. So is in, how do we check if it's one of yes or y? We could use a list, right? That's fine. We could use a tuple. That's fine too. But we can also use something else, which is a set, which is essentially a bunch of items where the order doesn't matter. Okay, so and then when you want to look if something belongs to a collection, sets, by the way they are implemented, we'll see that later, are more efficient. Plus, it's more natural, right? Of course, efficiency doesn't matter if you have two elements, no efficiency issue. But it's more natural to think of yes and y as a set, right? You have no reason to say yes comes first and y comes second. So it's always good to choose what is most natural for what you want to represent. So if that's the case, if our normalized yes or no is yes or y, then switch will be yes, we want to switch. Otherwise, so else if, elif, yes or no is in no, or n, then we set switch to false. We don't want to switch, right? Otherwise, we're not happy. So either, so this will always be executed, right? So either we need to convert to lowercase, or we don't need to. And after this line, whether we have normalized before or not, at this point we perform the test, and we break out of the loop if the input is correct, either because it corresponds to yes or because it corresponds to false. Right? Make sense? Yes?
Why not just, this method seems a bit confined, why not just convert it to lowercase regardless of this?
That's for the reason, because if I do that, I'm going to accept all uppercase or lowercase y, uppercase e, s. Right? Because you see, all of that is converted to lowercase. Right? You see? Of course, we could say, what's wrong with this input? And it would be perfectly right to say that's valid user input, right? But just for the sake of the exercise, just to learn a bit more, we have some stringent conditions on what is valid input. We say that's what we want to be valid and nothing else, right? So for that reason, we can't straight immediately convert to lowercase, right? Because then we lose too much information about what was the original input, right? That's all. So let's try. What's wrong? Not is in. So yes, Python reads like English often, but not still. If yes or no is in this set, so is implicit. Maybe. It doesn't seem to work, right? So why don't we say incorrect input? That's right. So what happens if we get the input? Maybe this fails. Don't need to normalize, so we go there, right? We check if this condition holds. It doesn't. Then we go there, we check if this condition holds, it doesn't. So, but there is nothing wrong in terms of a value error, right? So we go back to the top of the loop and try again. Do we need this exit value error? No, right? Nothing is supposed to trigger an error, right? This is a different kind of technique where input returns always a string, and we just analyze this string. So I guess what we need to do is to get rid of this except clause, and as you mentioned, and then say, well, do we need an except clause in this case? Probably not, right? Maybe. So now, because the print is part of the loop itself, right? So this is false. We go there. This is false. We go there. This is false. So we get to this line. We express our dissatisfaction and go back to the top of the loop. So that should also not be good, but that now should be good.
Can we inform the end user about this rule? What's wrong with that?
On, yeah, we could do that as well, right? We could also.
Always return incorrect input, or none of the is correct, right?
Even you're not happy with that?
Yeah.
Yeah, that's okay.
I need to tell the end user.
Yeah. Again, no, it's just a convention, right? I agree. No, it's we could be much more tolerant and say, well, that's perfectly fine, right?
I'm not telling you that's perfectly fine. I'm telling you I need to tell the end user that yes, focus all capital letter is false.
Right. Sure. Yeah, you are right. Yes, of course, I could make things much nicer to explain to the user that this is what I expect from you. Yeah. No, we're not writing a perfect program, but just learning a bit of syntax as we go. But you are right. It's not, of course, it's not very good to not tell the user what we expect from him or her, right? And the user is not meant to guess that this is correct and anything else is incorrect. You're right. Okay, so now that we know how to prompt the user, we can start the simulation. So we have 3 doors, A, B, and C. And I guess we are going to work with these 3 doors, right? Door A, door B, door C. So how should we present the doors? What structure is the most appropriate? So if you ask the question we asked before, first, does the order matter?
No.
It doesn't matter, right? Because indeed, we don't care if A comes before B, right? Even though we put A first, but it's just because we need to draw things in particular order, but otherwise, conceptually, there's no order. So from this point of view, a set would be better, right? But I won't use a set for technical reasons that we're going to see, and instead use a list. So, except for now, for a few minutes, that even though it would be most natural to do this, that's the case where natural is not good enough, because Python has technicalities that force us somehow to work with a list. So what do we want to do? We want first to put the winning door, to choose the winning door as being one of A, B, or C, right? So we want to randomly choose one of A, B, and C. So how do we get a random choice between A, B, and C? Well, we, from the random module, import the appropriate function. So let's do dear random to see what random has to offer. Well, for that, I need to first import random, because now Python doesn't know what I mean by random. So I first import this module, and then I'm able to find out what the module has to offer. And I could do the same technique, but to eliminate all these things which are special. But I still would not eliminate these things which are special too. But what is of interest is over there, right? So what is of interest in random? I want to choose a particular element amongst A, B, and C. So I guess choice seems like a natural choice. So from this module, let's import the choice function. And now I can call this function and randomly choose one of A, C, 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 C. Can I have B, please? B. And I expect, on average, to have one set of A, one set of B, one set of C. All right? So we see that's the technique where from a particular module you import what is of interest. Another way would be to import the whole module, but then this function, so import the whole module, but now I need to restart the kernel, because now starting from scratch, what we find out is that Python doesn't know what we mean by choice, right? It knows about random. So knowing about random, now it can access from this module any function in particular, not import, but in particular this function from this module, right? So either you import the whole collection of functions, and then you say, I want this function from what you now know I'm going to work with, right? Our second method is what we did first. From random, just import choice. And now if we start again, we start the kernel. Is that going to work? No, because it will tell me, but what do you mean by random, right? I only know of choice. Okay? So if this is the syntax you want, then you should call the function this way. Okay? So, yeah. So I guess this choice of door will be the winning door, right? The door behind which we put the car. Fine? And then we ask the contestant, which door do you want to open? First door. So what do we do for that? We can call choice again, right? So let's still print out winning door just for us. We could do that. Let's choose a door. First choice, sorry. So sometimes it's the same, sometimes it's different, right? And then we have to work to continue the simulation. So I guess we have to open another door, and then the user will either stick to his choice or ask the third door to be opened, right? So we're going to work with nothing but the other two doors besides those which have been, besides the one which has been chosen, right? So to work more easily, I guess we can just remove this door chosen by the contestant in the first place from doors, right? That's one option. We could say, let's now, from doors, remove first choice, because everything we need to do now will involve the other doors, and it will be easier to work with two doors instead of three, one of which we have to ignore, right? So let's print doors at this point. Right, so you see, if winning door is C, his first choice is B, then we remove B, first choice from A, B, C to get AC, right? B, A, and we're left with B, C, so on. Right? Make sense? So that's where we have the answer. If we decide X to be the set A, B, and C, which is more natural, and if from X we want to choose something, there's choices, what's good, X, what do we find? That's a bit mysterious, right? First thing we notice that choice doesn't work. So what's the reason? Set object is not subscribable, which is one way to say that elements don't have an index, right? Elements are not ordered, so they have no index. So that and the reason for that is that the way choice works is by generating a random number between 0 and the length of the list minus 1, and say I return the element at that location, right? That's how choice works. Generate an index and then return the element at this particular index. All right? So what happens? Choice doors is going to return, essentially, behind the scene, 0, 1, or 2, right? And then we give you A, B, or C respectively. Then we have to remove A, B, or C. How can that happen? Well, by going to the beginning of the list. If you want to remove C, let's say, if you want to remove A, go to the beginning of the list. That's A, I remove it, right? If you want to remove C, you go to the beginning of the list. A, that's not good. Let's look at the next element. That's B, that's not good. Next element, that's C, that's good, I remove it. All right, so you see remove works on A, B, or C, so on the element, so has to scan the list to find the element to be able to remove it. Now, instead of removing an element from a list, we can also pop an element out of the list. A, B, C. I could use again dear list to show you that lists have a pop method. So you can apply the pop method to any list, and what you get is what do you get? If I do that again and again, how does pop work? It pops the last element, right? So pop, first call to pop, removes D, returns D, and leaves X without this D. You call pop again, you remove what is now the last element, C, and the list becomes AB. Pop a third time, pop a third time, a fourth time, and of course, if you pop again, what will happen? Probably an error, right? If you say there's nothing left in your list. What kind of error? Index error. Okay. Because indeed, pop can also take as an argument. So here, pop takes no argument, right? Which is the default, which is the same as -1, right? The last element of the list. That's what the default is. But you can provide as an argument anything, any valid index, for instance, 0, or 1, or 2. All right? Make sense? So that's much more efficient than remove, right? Because the way things work behind the scene, when you have a list, right? So you have a list A, B, C, D. Sorry. A, B, C, D. They're actually not exactly stored consecutively in memory, but you have A stored somewhere, you have B stored somewhere, and your list says A. That's where A happens to be. And it will, just next to that, it will tell you A. That's where B happens to be. C, that's where you find C. That's where you find D, right? That's how a list works. So you have the beginning of your list that give you consecutively the locations of all your elements, right? So when you go to, when you say my L of 2, okay, from here you say I want the element of index 2, so I want the third element. So you know you have to jump over these two areas of memory, right? You can jump directly from the beginning of your list to that point to find where is located the element you want. So you see, this takes constant time, right? If you work with indices, you can access the location, the element you want, in constant time. So in other words, POP is more efficient than remove, right? POP working with indices is more efficient than remove working with elements that you have to find first by scanning the list. So we should prefer POP to remove. But for that, if you want to replace remove by POP, first choice should not be one of A, B, or C, but should be an integer between 0 and 2 included, right? So from random, we can import round range. Okay, so we haven't seen the range function yet. Range of 3 is actually something which can generate an iterator. So if I say give me round range as a list, I get the list of all elements in the range from 0 up to 3 excluded, right? So round range is the counterpart to range where you ask to get at random an element, an integer between 0 and 3 excluded, all right, 0, 1, or 2. So I guess that should be what you want to pass an argument to POP, which will return what you want. Make sense? Round range returns at random 0, 1, or 2. Then we pop from those the element at position 0, 1, or 2 efficiently. And what has been popped at that location is returned by POP and assigned to first choice. Right? So first choice gives me C, and then I pop out of those what is at position 2, so we can guess that one range of 3 return 2, right? And that's what we get, C and AB as output. Now one range returns 1, so we pop the element at position 1 out of the list, which becomes AC and so on, right? Fine? Good. So what do we have to do now? We know the winning door. We have the first choice by the user, contestant. This door is out of doors, so we can work more easily with the other doors. So then we need to figure out which door is going to be opened. All right? And now we have two options. Either winning door, either first choice is winning door. All right, so let's say B hides the car. I choose B. So what does the host have to do? It has to choose either A or C, right? It has the choice. Fine. If I choose the winning door, then the host can use either the one with the goat or the one with nothing. And he can do that at random. And again, what the contestant chooses can get out of the list so that what remains will be the contestant's second choice, right? So it's also convenient at this point to say, let's remove the open door to make life simpler and be left with nothing but what has to be the door that will be opened in case the contestant chooses to switch. And of course, if it doesn't switch, then we know what will be open, the first choice, right? So in other words, I should say open door equal to same technique as before, right? Tell me doors now has two elements, right? You are shy or not with me? Right? Doors now has two elements because we have removed the winning door. We have removed the first choice, right? Which happens to be the winning door. So now doors is a list with two elements. Nothing behind the door, a goat behind the door. So we want to choose at random one of these two doors, right? And say, let's remove it to make our life simpler. So doors pop run range of 2, because now we have only two doors, right? So generate at random either 0 or 1. Okay? Otherwise, in case first choice is not winning door, that's right, yes, so no, I have no choice in this case, right? In case the winning door is not the first choice, I'm left with the winning door and the other non-winning door, and I don't want to open the winning door, otherwise it's too easy for the contestant, right? So what I can do is, from doors, remove the winning door, and now doors is left with only one door, which is the one I have no choice and have to open. In other words, at this point, doors has two elements, a winning door, another one. I remove the winning door, so now doors have only one element, which is the door I have to open, right? So in other words, when open door will be doors of 0, right? Have only one element, so this element, of course, is at location 0. Okay? What will be the second choice? What is the second choice? Well, two options. Either I switch or I don't switch, right? If I don't switch, the second choice is known. Right? So I can actually take care of that outside of the loop, right? I can say that if I don't switch, then second choice is first choice. Okay? I don't switch, I know what will be the second choice. So then I have to determine what will be opened, that's what we did, plus what will be the second choice in case I decide to switch. Okay? So if I decide to switch, then second choice will be I choose the winning door, the host this winning door is out of doors. I'm left with two doors which are both not good. The host chooses one of these two not good doors, returned by pop, conveniently, so that now there's only one door left in my list, which is the one which will be chosen by the contestant, right? If he switches, he doesn't choose the first choice, he doesn't choose what has been opened, which he knows is not good. Right? So it's doors of 0. And in that case, if we switch, and the winning door was not the first choice, then what is the second choice? It's a case where we are guaranteed to win, right? You don't choose the winning door, so the host opens the other non-winning door, and you switch to, in that case, the winning door. That's what makes you win in 66% of cases, right? So second choice is winning door. Make sense or not? So let's say switch is false. And let's check that our understanding is correct. Open door, second choice. What is where does A become from? I can't see only one thing, which is output. Ah, there. Okay, you can see that. Right. So B is the winning door. We choose A. We don't switch, right? If we choose A, then the host has to open C, right? Because B is winning, we choose A, he has to open C, right? And A is what We stick to, we don't switch. Right? It's behind C, we choose C. We have the choice between A and B. We choose B, and we stick to C. And now we choose C, we choose B when the winning door is C. Then the host has no choice, right? It has to open A, and we stick to B. Okay? And if switch is true, B is winning. We choose A. So the other one, the third one has to be opened. C, and knowing that C is not good, switching, so not keen to keep A, we switch to B and we win. And that's the case where we are right in the first place, but unfortunately we switch to lose. Okay? Got the idea? You are lost in the logic, or? Okay, so let's put things together. So it may be good to first define a function to set up experiment. And this function will prompt the user to tell us how many times she wants to play. And second, tell us whether he wants to switch or not. Okay? That's our function. Let's use our function. Set up experiment. I want to play 10 times. Yes, I want to switch. Good. Our function has been called. Run. Are we happy? Not totally, because the function gave switch a number of times to play some values. But when the function returns, these things go away. All right? So we have to let the function return this value. Can a function return many values? No. Okay, so Python function can return only one value. Oops. So def f I call the function f, which does nothing. So if I write x equal to f, it means I expect f to return something. All right? So if this is the case, indeed, it executes. And then I try to print out to display x, and I get no output. So what's going on? X is none, right? So you see, if I want to display the value of x, and x is none, I get nothing. But on the other hand, if I want to print, if I decide to print x, then I get none explicitly, all right? So every function returns always something. If there is no return statement, it returns none. In case you want to be explicit, you can also return none explicitly. Same thing, right? But now you can return 1, we can return a string, can return two things, 1 and 2. Will that work? What will be the output? What do you think? It's going to return 1, right? When it returns 1, it's out. There's no 2. So how can we return both 1 and 2? This way. Do we return 2 things? No. Return 1 element always, which happens to be a tuple, right? So that's just, you see, the tuple 1, 2, where we left the parentheses implicit. Right? So Python is nice. This way, it looks like we return 2 things when actually we return only 1 thing, which is the pair, the tuple 1, 2. Right? And now if I know I want to get 2 things, then I can, instead of writing x equal to and work with x tuple, I can instead write a b equal to that, print a, print b. What is the syntax? What is the logic behind? Again, this is implicit tuple. Right? I'm assigning a tuple to tuple, a pair to a pair, by making the first element of the return pair the value of, or otherwise, I make a the name of, I make a point to the first element of what f returns, I make b the name of the first element of what is returned by f. Right? So, how do I fix this? By eventually returning number of times to play and switch. And I can use the same names, of course, the context is different, right? So here, number of times to play and switch, that's defined within the function, so known in the function and not outside. And here, outside the function, I define 2 variables which happen to have the same name, but the context is different now. It's the global scope. And it says I return none. So what's incorrect? Why do I return? It complains that I am trying to. Sorry? Number of times. It looks like I just forgot to execute the function definition. All right, so we have to be careful in Jupyter to run what we want. And now I can, I guess, display one and the other. I want to play 20 times. Yes, I want to switch. I don't know what that means. Yes, 20 true. Okay? So that seems to be okay. Of course, we'll have to check to test more carefully. And then I want to run the simulation, right? So what should I do? I guess do exactly what I did here. So set up the experiment. Right? And then do all of that. So let's make sure this is known already, but just to make sure the code is more self-contained. So I put everything there. Right, let me put everything in the same cell so you can see things taking shape. Right, so I import from this module what I want. Then I define two functions, one to set the experiment, and then one to run the simulation. To run the simulation, I call the first function, which gives me how many times I want to play, whether I want to switch or not. And then I'm conducting these computations. I guess I can say that contestant ignores it, but winning door is door winning door. And before that, I should probably say contestant decides to switch or not to switch, right? So decides either nothing or not, either nothing, right? Nothing or not to switch. So how can we do that? We can say, let's print this first. Let's not go to the next line. So let's make end equal to empty string, right? Then if switch is true, so if switch, we print nothing, but if not switch, then we print not with a space, and again nothing at the end, and eventually we print to switch. That's fine. Contestant decides, space, don't go to the next line, see if you have to print or not, not, depending on whether switch is true or false, with a space at the end. In case you do, not going to the next line, and eventually printing out to switch. Fine. Print. Contestant chooses door first choice. All right, and eventually print host opens door open door, and eventually contestant first chooses nicer, contestant now chooses door second choice, and we can say that if the second choice is equal to the winning door, then we can print contestant wins, else we can print contestant fails. Fine. What's missing?
Just adjust the open door.
Missing a colon. Right, this should be a colon. Now doesn't seem to complain. So let's run the simulation 20 times. Yes. Open door. Yeah, I decide to switch. So it happens to be C, which is the winning door. We choose A. Host has to open B, as we know. And now switching makes the contestant choose C, neither A nor B, and win. All good? Well, not quite, because are we playing 20 times? Not really, right? We're playing only once. So how do we play 20 times? I guess we need to put all of that within a loop. What kind of loop? We know we want to execute this loop that many times, number of times, so I guess a for loop is preferable, right? So for. So how do we make this loop execute 4 times? So one technique is to use range of number of times to play. If you remember, last week we saw for X in list, right, for E in L. That essentially looks at all elements of your list, okay, until the list is exhausted. So range is not a list, right, but it's something that from which we can generate an object to which we can apply next, and this for loop applies next, next, and next. Number of times I know we've got something bad here. Pop index out of range. Yeah, what's wrong? What is wrong is that we define doors outside the loop, right? So we execute the loop once. We remove from this list 2 elements. As the second execution of the loop, doors is left with only 1 element. So of course we have to restore doors at every iteration. So in other words, this should move from here to there, right? For every iteration of the loop, let's define doors as a clean new set of doors, thanks to which we can now we get a huge output. Right? So not ideal. So what would be better is, I guess, display all these things only if we have a look at the first few iterations, right? If you want to run this experiment for 2,000 times, you don't want to have this 2,000 long outputs. Right. So maybe the first 6. So let me show you something. Now we have number of times to play. That tells us how many times we have to execute this loop, but let's define new variable, number of simulations, or number of displayed simulations. Okay, so number of times we want to give the details. For the rest, we want just to give the statistics, which we still have to compute. So of course, we could ask the user to always tell us how many times he wants the details of this simulation to be explicited in this form. But we can also use what is called default arguments. Okay, so let's say we don't want to display more than the first 6 experiments in case we want to run this experiment at least 6 times. So you see, I'm now defining a function that takes a default argument. So let me show you this in more detail. Now I'm defining a function f that takes 4 variables, x, a, b, c, d. Let's print a, b, c, d. All right, so of course we know how to use this function, f for 1, 2, 10, 30. Good. But now I decide to give some variables a default value. For instance, I want to make b equal to 10. What happens? Is that going to work? What do we expect should work? We expect to give a the value 1, to give b the value 10 or 2? 10. So it's not clear. Let's try. Right. So that's not valid. What is it complaining about? That if I give default values, I should then not have any variable that get no value. So I can give d some default value, for instance 50. And now, having some default value, I can give c some default value, 40. And now I could give b some default value, and I could give a some default value. You see, so we have nothing but non-default values followed by default values. Now this is acceptable. And now what do we get? We make a equal to 1, make b equal to 2. And of course, if we want to give default values, it's because we want to sometimes override these values. That's what we do here, right? So we make c change from the default value of 40 to 10. So we should see 1, 2, 10, and 30. But now we can omit one value, in which case d gets the default value of 50. So we should see 1, 2, 10, 50, right? Or we could omit the third value, in which case we get 1, 2, and 40 and 50. And if you type f of 1, of course that won't work because it doesn't have a default value for b, right? So it's not happy with that. Fine. I can also explicitly give values in the function call. Okay, so now it's implicitly, right? It's based on position. But I can also explicitly say, A, I want to make d equal to 500, and I want to make c equal to 0. Right, and now you see you have choice in which order you list your elements. It doesn't matter if you put c before d or d before c, right? This is not ambiguous clearly. A and B get the values 1 and 2, and then we override the values of C and D explicitly this time by saying this is what is C, this is what is D, and the order doesn't matter. I could explicitly make B equal to 200 in any order, right? So I can also say this is C, this is B, this is D. But can I make A equal to 1 and then do this? What do you think? Same thing as for the function definition, right? The keyword arguments have to follow the positional arguments, right? So here in the function definition, here in the function call. Make sense? So you see that when you call the function, you will first have values by themselves, and you could have 0, 1, 2, 3, 4 values. It's fine to have 0 values, in which case you have to give explicit values to everything. You have to say, for instance, B is 2, A is 1, C is 3, and D is 4. Okay? Or you can leave the first argument implicit this way. Well, clearly not, right? Because now A has the value 2 by position and 1 by keyword, right? So that's fine if I make B equal to 1. Right, if I make now the second argument also position only, that's fine. And for the last two, I can give them by position only or by keyword in any position, right? So it's quite complicated, and it's not the whole story. We'll see much more involved ways of defining functions and giving arguments. Right, so you see I can use that here to essentially give a default value to the number of times I display the details. So I guess I should probably put that at the end. And say all of that is displayed in case I, the experiment number, is less than number of display simulations, right? Let's make it equal to 3. What is missing? Again, a colon. I want to play 1,000 times. Yes, I would like to switch. What is
the if statement indented into the
indent? What is indented?
the for loop.
The for loop, this one.
Yeah, indented if statement.
So what do I have to do with for loop?
Go to the if statement, move it into yeah. The if statement, like so if I
This one?
you print it, you move it in.
This one, this if statement?
No, the printing. Where you do
The printing statement.
where you print all the things, you can move it in. In there.
Is outside Yeah, it's outside the loop.
It's outside the loop, yes.
So it should be inside.
It should be within the loop. Because when I get out of the loop, even though I is defined within the loop, right? The loop defines I. Still, when I exit the loop, I is still known, right? So that's the difference between variables defined within the function and variables defined outside, right? We could think that since I is defined within the for loop, it's not known outside, but actually it is, right? So at this point, I has which value? The value it has when we exit the for loop, which is number of times to play, right? We exit when I reaches the upper bound. So now if we make that part of the body, 1,000 times. So we only show the first 3 simulations. Of course, it's not that great. Okay, so now we can decide to change this default simulation to 6. Right? Got it? Are we done? Well, we still should compute statistics, right? So what do we need?
Can we display M36 without?
You could also do that, yes, you're right. Yes. More work. Let's take care of number of wins. So something we initialize to 0, and which we need to increment. When do we need to increment that? So what do you think? If we don't switch, then when do we win? If we don't switch, we win if the first choice is the winning door, right? So you see, I get to this line when I should go there, right? So why do I get to this line? Because I forgot a colon. So now Python indents properly. So number of wins should be incremented by 1, right? So plus equal 1, same meaning as number of wins equal to number of wins plus 1. So we know what to do in case we don't switch, and we need to say what to do in case we do switch, all right? So if we do switch, either the first door was the winning door, in which case we lose, so no need to increment. And in case the first choice is not the winning door, then by switching, we win, right? So we also increment the number of wins in this case, right? Make sense? So you can now at the very end print proportion of wins. And that will be number of wins divided by number of times to play. 10,000 times. Yes, I would like to switch. Okay, well, it's not bad, right? It's 66%. So I guess I want to say times 100 and maybe print %. $10,000, yes. 60, except that I might not want a space. So if I want no space, what do I have to do? I can put separate equal to nothing here, and then put a space there. 1 million. Notice that Python lets you put underscores to make numbers more readable, so that would be 1 million times. Yes, we'd like to switch. Okay. If we only want 2 digits after the decimal point, we have to change the default formatting of floating points. So what we can do instead is to use a formatted string, all right? So I put F before the quote, and now I make all that part of a single string. I get rid of this, and I put between curly braces an expression whose value should be output. All right, so you see how it works. A formatted string is going to display literally all characters except for what is surrounded by curly braces, which will be an expression which will be evaluated, and what will be output is the result of this evaluation. So 10 million maybe it's a bit too much. Okay, it takes a few seconds. But I forgot to format, right? So when it's between curly braces, I can then add a colon and then give all kinds of instructions on how to display this value. So I can say it's a floating point number, and I want, after the decimal point, only 2 digits, or let's say only 1. All right, so floating point number display with only 1 digit after the decimal point. Okay, that's the instruction I give, and the colon separates what I want to output from how I want that to be output. So 1 million. No, I don't want to switch. There's something wrong there. 66% again.
You said the switch twice, and you say it's true.
I said true. 1 million times.
I mean in the code.
In the code. Yep, it's not my simulation. So in the code,
Second line,
shh. So in this function,
no, the
next
next line.
one,
This one.
yes, stupid xnid, switch has the value true or false, because I was doing that to test my code. So 1 million times. No, I don't want to switch. 30%. That's exactly what we expect. Okay, so it's not very clear.